Okay, so this is an example of an absolute value equation. So usually the first thing that I want to do is, let's say there was like a coefficient out here, or there was like a +2 at the end. Those are things that we'd have to move to the other side. That's called isolating the absolute value. We didn't have any of that to begin with, so then I can go right ahead to my second step, which is dropping the absolute value and setting up two equations. So the first equation should always look exactly like the original. Okay, I haven't changed anything except drop the absolute value. The other one, I, again, leave the left-hand side exactly the same, but I negate everything that's on the right-hand side. So when I negate something with algebra in it, you know, the x that means is going to become negative, but the 3 changes to a positive. So everyone on the right-hand side has to change signs, I'm sorry. Okay, now you can go ahead and solve like usual. Okay, then I just get the x by itself. So I get that x is -2. Okay, so then over here, pretty much the same steps. And so now I do get a fraction, that's okay. This is a repeating decimal, so I don't want you to write it as a decimal, you'd have to round, so I want you to leave that one as a fraction. Okay, so now that you have your two answers, you don't want to just assume you're done. This is where you want to actually make sure that you check both your answers to see if they actually work. Sometimes when we solve absolute value equations, we get what are called extraneous solutions. So probably most of you are going to do this in your calculator. I can't pull that up right here, so I'm just going to kind of show you what that would look like. So to check -2, you're just putting a -2 anywhere where you see an x. So if you were to plug this in your calculator, you can pause the video and actually go ahead and do that. You would get that the absolute value of -5 is equal to -5, and this actually is not true because the absolute value of -5 is +5. So this would give you a false check. Okay, so then we're going to do the same thing with 4/3. I'm going to try to squeeze this in underneath. So again, you're putting 4/3 anywhere that you see an x. Okay, so again, you'd probably just type all of this into your calculator. You end up getting that the absolute value of 5/3 is equal to -5/3. So it's the same kind of thing that happened on the other one. Regardless, you can't be getting a negative on the right-hand side, so this is also not true because, again, the absolute value of +5/3 is +5/3. So you actually, this doesn't happen that often, but it can happen. We got two solutions that didn't work. So actually, when you go to do your solution set, you shouldn't have anything in there. If you want to do this fancy symbol that means the empty set, you can, or if you want to just write no solution, that's fine too. Okay, so all that work and no solutions. Okay, so then let's also take a look at an absolute value inequality. Very, very similar setup. It's just that because it's an inequality, we're not just getting a solution set like a couple of numbers, we're getting an actual graph that would be like showing all of our solutions. So same idea as what I said before. If you ever have anything hanging around outside the absolute value, it has to be moved before you can do anything. So in this case, I'm just going to add that 2 over. So now I have that the absolute value of 3x plus 5 is less than 20. Okay, so now that part, like we did before, we're going to do again, where we drop the absolute value and set up two separate equations. So because we're dealing with inequalities now, the first one, like before, you're going to keep it exactly the same inequality symbol, everything. And then the other one, not only are you going to make the 20 negative, but you're going to flip your sign. So that's like the negative version, the second case that we have to solve. Okay, so now again, go ahead and solve like you normally would. You should get that x is less than 3 on the left. And this one we're going to get not so nice of an answer. And again, this would be a repeating decimal, so I don't want you to write the rounded decimal. I'm just going to have you keep it. I don't even think this reduces. So unfortunately, we do get x greater than -25/3. So again, since this is an inequality, I did say in the solutions that we're supposed to graph it and use set builder. So I'm going to go ahead just to the next slide because I'm out of space and finish that off. So when you draw your number line, -25/3 is smaller because it's negative. So I'm going to have that. Okay, and 3, and this was a regular old less than, so this has to get graphed with open circles. I went ahead and just put those solutions on this slide so we could look at them more. So again, if you look at this, this is saying that x is less than 3, which would imply that we'd be shading to the left of 3, but it's greater than -25/3. So this would be going this way. So this is one of those cases where our two solutions are going to meet right in the middle. Again, we do not overlap either of our solutions. So that's my graphical representation, and then I go ahead do my set builder. This is where, if you watch the compound inequalities video, you have two options. You can write this as one big inequality because it's in the middle. This is one smooth, continuous set of numbers. Or if you want to write them distinctly, if that big inequality confuses you, you can write your two solutions, but you have to make sure you use the word and in between. Because again, this is one set, so both of these things are happening at the same time. So either of those set builders is okay with me. And that's it.